Welcome to Spring LIB.
In this exercise, we're going to be talking about circular motion, so I'm going to briefly review it. Consider that we have a particle that's undergoing a circular motion, and we can decompose this particle's acceleration into two components. One of them is a centripetal component, and the other one is a tangential component. The centripetal component points towards the center of the trajectory and is equal to v squared divided by r in magnitude. V is the speed and r is the radius of the trajectory. And it accounts for the change in velocity of the particle. The tangential component is equal to the variation in speed of the particle and is equal to dv dt. So what we have in the exercise is a pendulum bob that has a mass of 2 kilograms. And initially, when theta equals 0, the initial speed of the pendulum bob is 6 meters per second. And our goal is to find what is the value of theta, what is the angle theta, when the tension on the string is equal to 0. Okay. So what I'm going to do is to draw a free body diagram for an arbitrary value of theta. Okay, so here is the pendulum bob. We have the tension that's pointing in the same direction as the string. We also have the gravitational force. These are the two forces that act on the pendulum bob. Notice that this angle here is theta. And what I'm going to do is to decompose the forces into two components. One of them is centripetal, and the other one is tangential. The centripetal direction I'm going to call r, while the tangential direction I'm going to call theta. So now notice that in order to decompose the gravitational force into r and theta, so what I'm going to do is to use that this angle here is theta as well. So in the r direction, we have t plus mg sine theta, and this is equal to m times the centripetal acceleration, that's v squared over r, as I said before. And in the theta direction, we have just mg cosine theta, and this is equal to m times the tangential acceleration. Okay, our goal is to find what is the value of theta when t is equal to 0. So I'm going to use the first equation and set t equals to 0. So mg sine theta is equal to mv squared over r. So sine of theta is v squared divided by rg, which means that theta is the arc sine of v squared divided by rg. Okay. But notice that we don't know what is the value of v squared when t is equal to 0. So that's something that we have to find. So in order to do that, what I'm going to do is to use the second equation for theta here. Okay, so we have that g cosine of theta is equal to at. Remember that at is dv dt, so I'm going to multiply both sides by v. So I have v g cosine of theta is v dv dt. Now remember that v is the speed of the particle, which at any point is equal to the element. So consider that this here is the trajectory. We want the line element, ds, divided by dt. So v is ds dt. G cosine of theta And this is v dv dt, so the dt's cancel out. Now remember that the s, the element of arc length, is L times d theta, where L equals 2 meters is the length of the pendulum. So what we have is GL cosine of theta, d theta, is equal to v dv. And now I have to integrate it from theta equals 0 to the final angle theta. And actually, I'm sorry, there's something wrong here. There's only a minus sign lacking, because notice that as the pendulum bob starts to go up, the acceleration is negative because gravity's acceleration is pointing downwards. And as a matter of fact, it would be more appropriate if I chose the coordinate system to be like this, okay, so that the tangential acceleration is actually making the pendulum bob go slower, okay. The other way wasn't particularly wrong, but it would make calculations a little more difficult because we would have to take a lot of things into account. Here, I'm just taking AT to mean that the acceleration is pointing downwards. Okay, so the value of the acceleration is negative. So this means that everything from here has a negative sign. I'm sorry for the little confusion. It's just a matter of sign. So we have to integrate v from 6 meters per second to a final value of v. Now remember that the integral of cosine is sine, so we have minus GL sine of theta from 0 to theta, which is just sine of theta, and this is equal to v squared divided by 2 minus 6 squared divided by 2. Okay, so v squared is equal to 36 minus 9.8 meters per second squared times 2 sine of theta. So v squared is 36 minus 39.2 sine of theta. And this is the value of v. Now we can go back to the equation that we had before, this one here, and substitute it here. So we have sine of theta, and actually we have g times r sine of theta is equal to v squared. So we have rg, that's 2 meters, sine of 9.8 sine of theta is 36 minus 39.2 sine of theta. So we have that 58.4 sine of theta is equal to 36. So the sine of theta is 36 divided by 58.4, which means that theta is equal to the arc sine of 36 divided by 58.4, which is equal to 38.1 degrees, which is the answer to our exercise.